7, we've got the integral of x squared times the sine of pi times x dx. All right, so you wrote this down in your paper. What were your first thoughts?
I worked it out. I just don't know if I worked it out right. What I did is I did the integration by parts right away.
Okay.
So my u is x squared.
Okay, and that makes sense. Liate, algebra comes before trig. Okay.
And my dv is sine pi x dx.
Okay.
My du is 2x dx.
I totally agree. Okay.
And then for that one, I did a u sub.
Okay.
So then it ended up being negative 1 over pi cosine pi x after I did it.
Okay, so you sub u be your pi times x, and what do you come up with?
Du over pi equals dx.
Oh, okay. Okay.
And I put my 1 over pi in front of the integral.
Okay. So in the end here, you've got the integral of sine u du over pi, so you can pull the 1 over pi out front.
Yeah.
Sine u du. Okay, sounds good.
And then the integral is negative cosine. So.
Okay, so we've got negative 1 over pi times cosine of u plus c. So when we go up here, we've got negative 1 over pi cosine of pi x.
Yep.
Okay. Seems very valid. A very similar pattern happened here that I want to point out as happened over here when we had just a number in front of the variable. When we took that antiderivative, well, a 1 over that number popped out as part of our antiderivative. Okay, great. So we've got all the parts. Any questions about those parts? Okay. So we've got uv. So let's see, our formula is the integral of u dv is equal to uv minus the integral of v du. I probably have that written up in the margin of my homework, but I'll write it every time here. And so we have u times v, so we have x squared times negative 1 over pi times cosine of pi x minus the integral of v, negative 1 over pi times cosine of pi x dx. Oh, sorry, cosine of pi x, integral of v du, so times 2x dx. All right. So life is good at the very beginning here. I could clean this up, negative 1 over pi times x squared cosine of pi x. And this part I definitely want to clean up. Okay? I'm going to pull my constants into the front. So the negatives will cancel, give me plus 2 over pi. The integral of x times cosine of pi x dx at the end. All right, so I look at this integral, and here's where I want to make a judgment. I want to pause here. I don't want to just keep going forever and ever. I want to say, am I in a better place than I was when I started? And when I started, I had an x squared times the sine of pi x. And in this new integral, we've knocked off one of the x's. So life is getting better, but I still don't like this because I still have multiplication going on here. And so when I look at this integral, I say, okay, how am I going to find the antiderivative? Well, I'm going to have to use integration by parts again. All right, so my integration by parts again, I've got a u and a v and a du and a dv. And so I am slightly happier. I've gotten rid of the x squared, we've knocked it down to an x. Algebra still comes before trig. So our u is equal to x and our dv is cosine of pi times x dx.
On mine, I didn't do what you did over here and throw all the 2's and stuff in front.
This one here?
Yeah, I left it 2x dx and then I did it like that, but that's fine though, right?
So you can leave these coefficients in there, and that's totally
Well,
fine.
I brought the negative 1 over pi out. I just didn't bring
okay.
I didn't bring the 2 out.
Which is fine. You can leave the 2 in there, and then let the 2 maybe be part of your.
Yeah, that's what I did.
So that's totally
So
legit.
then I brought the 1/2 out then.
So yeah, so that's totally fine as well.
Okay.
Okay, other questions or comments? Okay, so when I do this antiderivative, again, I'm going to have to do a u substitution where my, and I won't write this completely out, but my u substitution will be u is equal to pi times x. And you should check that this is going to be equal to 1 over pi times the sine of pi x. So we end up with all of our pieces. And so now we can look at our integral again. And man, there's a lot going on here. I have this whole beginning part that I'm going to write down. So my whole beginning part is negative 1 over pi x squared cosine of pi times x minus, oh wait, do I want a minus there? I do not want a minus there. Plus 2 over pi. And the 2 over pi is times this entire integral, which means it's times whatever else I write down. So I want to make sure that I have the 2 over pi, and then I have a bracket to contain everything after that. So I have 2 over pi, I've got u times v, which is x times 1 over pi sine of pi x. So uv minus the integral of v 1 over pi times sine of pi x du, which is equal to vx, and bracket. So at this point I stop again, and the first thing I do is ask if there are any questions about that. Okay. After that I ask myself, am I in a better place with this integral that I have left over? And the answer is yes, because now not only do I not have an x squared, but I don't even have an x, so I've reduced the number of x's each time until I have no x's left over up here at all. And so at this point, this integral, I could clean it up by pulling the 1 over pi out front, but essentially this guy is going to be a u substitution. And you should check that the integral of sine of pi x dx is equal to negative 1 over pi cosine of pi x. And in fact, we actually already did that over here. Okay, and it shows up again. So the nice thing about integration by parts is you get to reuse pieces that you've already done. And so our final answer, negative 1 over pi x squared times cosine of pi x plus 2 over pi times the quantity x times 1 over pi times sine of pi x minus, okay, I've got 1 over pi and then I've got a negative 1 over pi, so that becomes plus 1 over pi squared times cosine of pi x. End parenthesis, tack on my plus c. All right, final answer. All right, are there any questions about this one? There's a lot of calculus and algebra that go into this problem.
I got the same answer, except I got 2 over pi squared.
At this point here?
Yeah, and it's because I used the 2 dx, you know, I didn't put the 2 in front of it like you did.
Mm-hmm.
That's where that mistake's coming from.
Oh, so when I think about this 2 over pi here, when I pull that in, then I'd have 2 over, so your 2, you'd have a 2 here, and you'd also have a 2 in the front here.
That's exactly how I did it.
Yep, so all I had was I had that 2 outside the parentheses.
So
here.
my way would be right too?
Yep, absolutely.
Okay.
Okay, other questions about number? Okay, so let's take a look at number 9.